Hello folks, I'm going to build the model from figure 3.2 in Ford. I just want to walk through this to get you used to building models, to talk about reciprocals, and to just go over a few things so you can see my thinking as I'm doing this. And I want to do this in a video. I felt if I did this in class, I'd lose too many people. And with a video, you can go back and go over this slowly. And hopefully you'll build the model or follow along and build the model as I'm building the model. So I'm looking at the figure right now. And what Ford's done is he took a simple population model and he broke it into 3 different categories. He hasn't provided any of the values or anything. It was just being used as a stock and flow diagram really, and not a model. I'm going to turn it into a model. So I'm going to go up to the top left, and I'm going to click on the stock, and I'm going to click here, and it's going to open my stocks. One of the other things, in the default, I have gone in. If I go to my Stella preferences, and you can see my defaults, I have this non-negative clicked off is what it is. I leave it as uniflows, but you should have these non-negative clicked off. And what you'll see in the bottom right-hand corner of your stocks is plus and minus. It means the stock can go negative. And if you think about this, I've just dragged this into the middle, and I'm going to label this instead of stock 1. He said young population. I'm going to click on this and hit a return right before my P, and I'm going to grab this bottom box and just make this larger. So I've got my young population, and this is going to be in people. And if you think about this, people could never go negative. The plus and minus means this stock could go negative. And if I saw negative people in my model, I would know my model is wrong. So one of the reasons I want this preference selected so your stocks can go negative is if you write an equation incorrectly, then your stock is going to do something that it shouldn't be doing, and you're going to be able to notice this easier. If you've forgotten this, it would be okay also. What will happen is if the stock goes negative, then this would turn yellow, and that's an indication that something isn't quite right. So I've selected my first stock, and I put in this young population, and I like the size of this, so all I'm going to do is I am copying this, and I'll click and I'll paste again, and it puts a 1 at the end. You can't have variable names that are the same. You can see there was a thin line in there, and I'm going to copy and paste one more time. And you can see this gray area. If I drag any of my icons into the gray area, it just fills out and is my working area then. And so I'm just going to go and label these. So this was called mature population. I tend to capitalize all my variable names, and I'm thinking if I ever write this stuff up, I want to be able to distinguish between a variable in the model and the meaning, and hopefully I'm writing variable names that have meaning. But I'm writing this, I'm capitalizing all my variable names. So I'm going to go in here, and this is the elderly population. I'll get rid of that too. And I have my 3 stocks. And now I'm going to go up to the top left, and I'm going to click on this flow icon. And I'm going to click over on the left and just drag it in, and this is going to be my births. I'm going to click on that flow icon again. I'm going to make sure I'm right on top of my young population on the stock. I'm going to click and I'm going to hold down my mouse key, and I'm going to slide over until I'm on top of my mature population, and I'm going to let go. And this is going to be called maturation. And I'm doing the same thing. I'm going to click on the flow variable, click on the mature population, drag it over while holding the left mouse key down. And when I'm on top of my elderly population, I will let go. And this is labeled aging. And the last variable is going to be deaths. I'm going to click on the flow variable, be right on top, click and hold, pull it out to the right. And this is going to be deaths. What I can do now is I'm going to click on all of this and just drag it to the right. I've noticed one other thing. I've jumped around. I'm going to pull it down into the middle. I'm going to click on this, and I know that my start time is 1 to 13. That's the default. I'm going to highlight this and start at time 0. I'm going to run it out for now for 100. And my time units, I would like it to be years as I'm dealing with a population is all. So I've got that running out to years. The Euler method is fine for this. So I'm going to click, and I've got this started. And I'm just going to add, you should always have a running model, but I'm going to be adding things in here. And I'll start with my fraction female. So I've clicked on this converter, and I've clicked here, and I'm going to type fraction females. What I've also done too in my model, if you double click on the white space, it'll open the window on the right, and you can go down to your, this is a paintbrush on these icons in the lower level. If you click on this, you can see I have things selected at 18. And if you go down to the converter size here, it says name only. If I go with median, it's going to be a circle here. I like having it name only, and that's why mine looks like this. Yours may look different. I'm going to click in and square this up. I have females only. I'm going to add in my mature females. And I will click on the converter again, and he has the births per mature female per year. And then he has these maturation rate, click on the converter again and come down, and aging rate, and then he has a death rate. I'll click on my converter, come down here, and there's a death rate. And he has one more variable up here, which is the total population. And now I'm going to go and start connecting things. I'm going to click on my connectors, and I know the stocks are all connected to the flows. So I'm going to click and hold down my mouse key and go over and connect right to the valve. I can click on this variable name and slide it around. I'll do it for the others. I know I'm going to be approaching everything from the bottom. I'm going back to my connector, and the maturation rate connects to maturation. Connect on the connector again, and I will go from my mature population to aging, clicking on the connector and going from aging to, or aging rate to aging. I'm going to do the same thing one more time. Click on the connector, go from elderly population to deaths, click on the connector and go from death rate to my deaths. And now, excuse me, I'm going to go from my mature population to my females, mature females. And I'm going to go from the fraction, clicking on the connector, to females. And then the mature females is going to connect to my births. And then my birth rate, or my mature female births per year, will connect to my births. And you can see there's triangles in here indicating that I need to put in equations for these things. So I'm just going to start out. I'm going to click on the young population, and I'm just making a guess. He hasn't provided me with any information. So I'm going to just type in 100. And I'm going to go down to my units, and I'm going to put the units in here as people. And this is going to populate, because these are conserved flows, it knows that it has to be the same units passing through everything. The software automatically knows that this mature population also needs to be in units of people. It's filled that in for me. And I'm going to start out with 100 people in here. And then I'm going to go to my elderly population. Again, it knows that it has to be in people. And I'm just going to start out with 100 people in each of these different age groups. My fraction females, again, no information. I'm assuming this is a human population, so I'm going to put this at 0.5. 50% of my population is going to be females. And this needs to have units, and it's dimensionless. It's a fraction, really, is what it is. It has no real units. It's just a fraction. I'll type in dimensionless and click on that. And then I'm going to click on mature females, and I have two connectors coming in, two causal links here. And with my mature females, it's going to be the mature population times my fraction females. So if I have 100 in here, 50 of them would be females. And I'll be capturing that here. So I have to put the units in, and this is dimensionless times people. Dimensionless is just a fraction. It's like 1. So this is just going to be people. Now I have that selected. I'm going to go to my births and double click on this, and it's going to be my mature females times my births per mature female per year. Because I've selected years in my simulation, it knows it's got to be the stock and whatever the time units are, so I get people per year. Flows are always going to be in whatever the stock is per unit time that you've selected for your model. So now I'm going to go with my maturation rate. And what's occurring here, this is a rate down here, so this is going to be a fraction also. So if I double click on this, it's going to be my population times the rate at which they're aging. And it's going to be the same thing all the way down this aging chain. It's the aging rate times my mature population. For my aging and for my deaths, it's the death rate. It's the fraction of deaths per year, really. Death rate times my elderly population. And the units are all selected for me here. Now I have a few other units to figure out. So how long are they going to be considered a young population? And in this case, I'm thinking I'd want them to go for 20 years. And in my world, it's sort of perfect. So we're going to have no teenage pregnancies is what's occurring. Everyone's going to wait until they're at least 20 before they start having kids. But I need to turn this into a fraction. And I'm going to jump to my spreadsheet right now in Excel. And so what I'm going to do is if I wanted them to be 20 years old, that's the number of years. Let me do this correctly. This is going to be years. I'm going to put a 1 in here because I'm converting it to fractions. And this will be the, they call it fraction aging rate. I just wanted a generic term here. Let me make this a little bit bigger so this all fits in. And I'm going to go in here and put an equal sign in, and all I'm going to do is take 1 and divide it by this 20. So I'm turning this 20 years into a fraction as all. So it's going to be equivalent to my young population aging for 20 years. So that's going to be 0.05. So I'm going to go into here, I'm going to click 0.05, and this is fraction per year. So this is going to be dimensionless. Click on that. And it's per year. And when I say per, I want a backslash. And then I'm just going to type in year. And so now I've figured out for 20 years they're going to be in this group. And I'm going to allow this population to go to 25, or I want them to be 45 before they stop having kids. So any woman in this age group from 20 to 45 is capable of having children in my world. So I'm going to go back to my spreadsheet, and I know that 20 to 45 is going to be 25 years. So all I have to do now is type in 25, and this tells me this fraction should be 0.04. I'm going to click in 0.04, and I've just double-clicked on this to open up this equation editor. And I have to put the units in, and I can click. It's not showing up in your screen. I'm going to go for it's dimensionless per year, right? Dimensionless per year. And then the death rate. So now they're 20 years old plus 25 years. This puts me to 45. I'm going to allow my population to live on average to 85 years is what it is. So this is an additional 40 years after they turn 45. I'm going to go back to my spreadsheet. And I know an additional 40 years. I'm just going to type in 40, and this is 0.03. 0.03. And this is going to be dimensionless per year. And you can see because I've already selected it, it pops up. So I'm going to click on this. And this ensures that my spelling is always correct. So we have these. And now with this total population, this is a different way of doing this. I could connect these links to my total population, but that's not what he did. So if I click on this, I'm going to right click on total population. I'm going to go to change type, summing converter. And now it pulls up this. I can click on this plus, and I know it's going to be my young population. Okay. Click on the plus again. It's going to be my mature population. Okay. I'll click on the plus one more time. This will be my elderly population. So it's the sum. These are actually being connected to it now, though it's not showing it. And the units are going to be people. They have to be the same units as the things coming into it. And the last thing is my births per mature females per year. I'm going to click on this. See, I didn't keep that with a capital. So how do I want this to be? Thinking, what is the population growth rate? I'm going to guess right now and say 0.03 because I know in the United States we're a little less than that. Historically, we've been at about 0.03 or 0.04 for the population. So I'm going to just put that in. And this is a fraction per year or dimensionless per year. And there it is. And now everything's selected and I'm capable of running. All the triangles have disappeared. I'm going to go up here and click on the graph. And I'm going to make a couple of graphs. Here's one. And so on a Mac, I can hold the command key and click on the population and drag it over to here, or I can go into the right and click on the plus sign. And then I'm going to go down and look for total population, or I could type it in up here and click on total population. Okay. And I'm going to make this a comparative graph. And I'm going to go in and click on numbers here for my marker type. This is showing up nicely, and I can hit run. Shows my population is declining. So this is sort of a big deal already. My population, I started out with 300 people, and my population is declining. And the only way my population could decline is if the outflow, the deaths, are greater than the inflow. So this population is declining. I'm going to add one more graph up here. I'm going to go up and click on my graph. I'm going to move my population. Make this a little larger. And what I'm going to want in this graph is I'm going to click on the plus. I want all my population. So I want my young folks. Click on the plus. I want my mature population. So mature population is growing before it's declining. And click on the plus, and I want my elderly population. And my elderly population is growing and then declining. So I want to label this. I'm going to go down to the wrench and click on this. And this is I'm going to label this. This is population stocks. There's no right or wrong with this labeling. It should make sense, is my argument. So I have selected that. I'm going to go back to the graph down here below and click on numbers. And what I've also done is, if you double click on the white space, you can go into the graphs here. By default, your thickness is going to be 1 on all of these. I've just gone in and clicked and made them 3. And I click on this up here and go down into this thickness and selected these. And I do this because I just like the lines to show up a little bit better. So I've got these graphs and I'm capable of running this now. And it seems as though my population should be increasing. I'm just clicking on this stuff and going in and squaring things up. Pretty good shape. So I'm thinking the population should be growing, and why is my population not growing is the question. And I know, compared with all these stocks, my births are less than my deaths. The inflow is less than the outflow, and that's why the population is declining. I would assume with a population and no limits on their resources or anything that the population should be growing. And I think my mistake as I trace through this, my mistake is that I'm thinking 0.03 is going to be too small of a population growth rate. But I know in my mind that when I look at the data, that the population growth rate for a lot of these places is around 0.03 is pretty fast growth rate. But when I think about this and I think about the model, what I've done is I've got this mature population for 25 years. And I believe those 0.03s are for the whole population, whereas this is a growth rate just for my mature population is what it is. So I just want to start thinking, what's going on? How many women are my population, or is my population having? I'm going to go back to my spreadsheet. I'm just thinking through the logic of this type of stuff. And I think with modeling and seeing the behavior, this is where it's valuable in that it makes us think about what's going on. And so I've got these folks in here for 25 years is what it is, right? The birth population is for 25 years. So over 25 years, how many children would one woman have? And it seems as though to be in equilibrium, we would want replacement. We would want them having 2. I don't know if I'm right. I'm just figuring stuff out. So I'm going to put, if they were to have 2 kids here, what would be happening? And then I'm just going to do a calculation. So this is over 25 years. I want to have 2 kids. What would my fractional birth rate need to be in that case? I'm going to put an equal sign in. I'm going to take the 2 and I'm going to divide it by my 25. And this tells me that my birth rate should be 0.08 for this age group of population in order to generate something that is close to equilibrium. So let's see if we start out with that. So I'm going to double click on this. I'm making this change permanent. So I'm just going to type in my 0.08. The units are still the same. I'm going to click on simulate and run. And we can see my population now actually grows slightly. And now I'm more towards equilibrium. And now that I've simulated, I can go in here and crank this around. And you can see that I actually am growing. And in here, what you'll notice also is that the pluses and the minuses are showing up on everything. I don't have to add these in because the software is calculating this based on the calculations that I have done. And now, if it goes up to 0.16, I have an exponential birth rate, which means I must have a reinforcing loop, which is here that is generating this. If I go over to the right-hand side, I can click on this flashlight. This is R1, and it says 2 stocks are in it. And it identifies the feedback loop. I can click on this icon and drop it in, and there's my R1 feedback loop. If I double-click on the white space and hover over this, you can see everything else is grayed out, and this feedback loop is selected. So I want to do one more thing, and I want to look at the reciprocals is what it is. So the maturation rate, the aging rate, the death rate, I just want to know how long they're living in here, right? And so I'm going to change a couple of things. So I've double-clicked on the white space. I'm going to change my variable name now. And I'm just going to call this time young. And I'm going to double-click and call this time mature. I'm going to click and call this, I'll leave the death rate as it is. I think it's a fraction of the elderly are just dying. And notice in this model, there are no deaths. No young people die, no mature people die, sort of a perfect world. But I changed this to young, so I don't want to make this a fraction anymore. And I said they were staying in here for 20 years. So I'm going to convert this to 20 from the 0.05. And now, instead of being a fraction per year, this is just going to be in years, is the unit. I want to do the same thing for my time mature. Instead of 0.04, I'm going to change this to 25 years. And I'm going to go down, the units are going to be years. I have to change one other thing. You see, I've got 2 unit warnings at this point. And I'll move this, let me adjust this. So I've got 2 unit warnings. If I click on this, you can see it names the variables where I have the unit warnings. So maturation and aging. I've got unit warnings in here. This is an indication that my equations are incorrect. I've changed this from a fraction to years. So if I go into my aging, instead of being multiplied, it should be my population divided by my time, divided by my time to mature. And I should do the same thing with my maturation rate. And it happens to be young population, stock divided by the time young. And if I simulate this, I'd anticipate that I'm going to get the same behavior. That I'm not going to change anything else. I should be on number 2 right now. If I go down and click on this run button, you can see the 3 is right on top. So even though I changed these values, I've taken the reciprocal, that I changed the equation in here and it's the same. And I'm going to jump back to my spreadsheet just for another minute. And so I think originally I had 0.05. I'll put the 1 in, and the reciprocal is, I'm going to divide the 0.05 into my 1 here, and this should be equal to 20. So I'm going to take the 1 and divide it by the 0.05. And there is my 20. And with the 25, I had 0.08, right? So I could put 0.08 here. Oh, what have I? Oh, this wasn't the time. This was the birth rate is what it is. So for the time I had, I'm drawing a blank on what this fraction was for the time mature was originally. It was 25. So I can back into this. I'm just going to back into that value. We're taking reciprocals, and you should be comfortable with doing this. So if I took the 25 years, it would be 0.04. So this was 0.04. And it works out to be 25. I've just flipped those. So that's just taking the reciprocal. So I could adjust these to be a fraction, or I could adjust these to be a time. I'd have to change the equations is all. It's the same model. So hopefully this gets you a little bit familiar with developing these models, with reciprocal, with putting some graphs in. There's a lot more to do, but hopefully by building this, it will be helpful in learning Stella and in learning some of these concepts and equations. Thanks, and I'll see you in class.